So I'm going to turn it over to Ben Mintz for a few minutes. He's going to introduce our presenter. For those of you that don't know Ben, he is also with NEF. He has been working with them in the Western PA area for 9 years, helping companies, manufacturers with their automation needs. So Ben, I'm going to turn it over to you to go ahead and introduce John.
Thanks, Molly. I don't think I've had a chance to introduce my my boss before on a presentation, so this is new for me. But I'll be, yeah, there you go. Thanks, Molly, or John. John Bridgen he's actually our team leader in Pennsylvania for NEF automation. He has been working in the automation field for 24 years with a range of positions in engineering, product development, marketing, sales, applications. He has a degree from the University of Pittsburgh in computer engineering. However, I think his degree now is really in solving problems that I create for him, and he does a fantastic job at that. He's going to attempt, and I'm interested to see how he does it, to present 16 automation technologies today in a matter of about 30 minutes. And we'll see how that goes. And to be honest, like there's some notes here about John, and you can read them yourself. I'm not going to read them to you. But John he truly has a passion, and it is automation. There's no doubt about it. But he also has a passion for life and a passion for his family, which he has 3 kids, and he lives outside of Lancaster, Pennsylvania. So without further ado, John Bridgen, you are up, and I'm excited to see how you present these technologies to us today.
Yeah, thanks, Ben and Molly. And I think Ben said it well there. We definitely have a passion for what we do. It's a common thread of the whole NEF team that I'm definitely proud to be a part of. You know, what we're going to try to do today is based upon, you know, specifically my experiences in manufacturing and what I observed from the team that I'm fortunate to work with. Kind of review 16 solutions that are either brand new or underused because they're just misunderstood or not known about. We'll try to cover them in about 25 minutes from now. You know, the idea of the 16 topics is to be concise. We will include budgetary numbers for all of the technologies. You know, the numbers could be made lower or could be made higher, of course. We just want to give you a way to hopefully calculate an ROI to see, hey, maybe this fits into your business. I often find technology without a budget can be confusing in the sense you don't know how to approach it, and hopefully with providing both sides of the equation, because all automation is just a tool to affect your bottom line. And if you don't understand the financial investments in the tool, then it doesn't connect well to calculating the bottom line. As such, we're going to take all the questions at the end. It is unfortunate, as I love engagement and interactivity and to be challenged, but through the 16 topics we're going to cover, any one of them could probably be a 2-hour discussion or more. So in the interest of everyone, if a topic doesn't apply to them, we want to move past it relatively quickly so we make good use of everyone's time. So please enter your questions in per Molly's instructions, and we'll handle those at the end. All of the solutions we'll present kind of have a few things in common. You know, they're shown here, you know, whether they come from advanced technologies, maybe energy savings, Industry 4.0, or labor shortage. So the 16 tools we're going to talk about are all different ways that affect your bottom line. You'll notice through the slides with those technologies, the 4 icons here are going to be shaded out if they don't apply. So as we get to a certain technology, it'll indicate if energy savings is a primary motivator for that solution with the same icons you see here. The icon on the bottom right with the multi-armed robot looking thing is my representation of advanced technologies. And then the factory with the Wi-Fi symbol is my representation of Industry 4.0. And we are going to put these solutions in terms of real products. And what we're not here to do is suggest these are the only brands that can be used. We're only suggesting the brands we know about so we can speak with them with authority and confidence, but we're just trying to raise awareness to general technologies. So with that, these are the 16 technologies, not in the same order that we will be presenting. And there's a wide range of subjects. If you're wondering how these kind of came to be, I literally just sat down and reflected upon things that we don't see adopted enough or understood well enough. Or as we talk to customers, they say, I wish I would have known. And we're trying to capture all of them here as concisely and briefly as we can. So as was the promise of this session, we want to respect your valuable time. Hopefully this is in line with what you were expecting. But if it's not, we would encourage you to leave the call now and maybe join a different one we have, because we don't want you to spend 25 minutes and feel like your time was wasted. That was certainly not the point here. So if you are going to stick around, let's get going. And I'm excited to chat about these solutions that I think can make a difference to your bottom line. This solution is really a preview of a tool from Cognex. The houses on the left are something that, as you can imagine, trying to teach a traditional vision system how to identify all four of those objects as a house. That would be very challenging with what's known as rule-based vision. That's kind of vision as you know it today. But if you think about how you teach, the kids that Ben mentioned I have, that those are houses, you do it more in general features, doors, windows, maybe size. There's obviously other attributes. And what's really exciting is this product, the Vidi product, uses what's called deep learning. It's a version of artificial intelligence that you do not teach with rule-based vision. You teach it by showing it images, and the system then learns. So it is artificial intelligence. What it allows for is approaching a whole new range of solutions, often in the quality areas, but not necessarily exclusively, such as the air filter shown on the right. In the bottom right, you'll notice a dent in the pleated section of the air filter. By streaming a number of these images into the system, the system will automatically start to learn. And it's so powerful, in fact, that features like the silver member that run across the frame aren't even a problem to finding defects right along that silver seam area. So if you can imagine what deep learning is, deep learning allows vision to be taught like you would teach a person. And what that does for you is it unlocks a whole new range of applications that really remove a lot of the variances that are caused by lighting. If you've ever implemented vision, you've probably struggled due to lighting concerns, and this is a lot more robust. You can see a few examples here of such applications. OCR, it can be very challenging, and this is an outstanding tool for OCR. Surface imperfections. On the right, you can see what I believe is a circuit board, or it could be a cell phone, I don't know. And you can see there's a scratch that's identified in the circle, and that scratch is highlighted in red. So that scratch in that surface was found with the Cognex Vidi solution. Another really powerful implementation to use this for is kitting or assembly verification. So on the bottom left image, you'll notice a kit. This is some medical devices. The supplier for these devices wants to make sure the package is complete before it's shipped. Vidi is capable of determining that, or perhaps you're trying to determine if a surface mount component is misplaced or missing on a board. So it really opens up a whole new area of application. And again, there's no programming. So it's a very powerful solution. You're looking at about $15,000 for a system like this. And one of the benefits of that $15,000 is, again, you're feeding it images and it kind of learns itself. So you're eliminating a lot of the programming that's often thought of that goes along with what's called rules-based vision. There is a webinar that'll detail this much more deeply as part of this series that will be held on Tuesday, March 16th. Speaking of advanced vision, another technology there that's really becoming prevalent is bin picking. Bin picking is being very preferred for a lot of reasons. It saves floor space. It often works within the package that the parts have been presented in. The the bins. Obviously, you use a bin to go from primary process A to B. A lot of our automation in robotics is around consistent part presentation. So you can imagine if you're able to use the parts as they are, that is a very big advantage. And that's kind of what bin picking is trying to accomplish. It's really gaining popularity, and we're seeing the technology maturing. There are many systems, a system like ActiNav is a built-in system that's specific for the UR robot. One of the reasons that's advantageous is ActiNav will help you automatically plan the path to pick up the part. If you look at the image in the upper left with the bin, while most all 3D bin picking systems can determine which parts are on top and sort of which ones have the best probability of being picked, how you program it to go in and pick that with the angles and all the other aspects can really be a problem for traditional bin picking systems. ActiNav automatically figures that out and programs the robot to approach the part appropriately. So that's one of the features of a system that's specific to UR. There are other systems that are shown here. Covariant, which is imaged in the center, is used with ABB robots as part of the Amazon Packaging Challenge. That can basically present a wide range of parts, and much like Vidi, it's learning them as they go. So it also attempts to, if it misses a part, so if you're picking apples out of a bin, it'll try to roll the apple so it's actually in a more presentable position automatically. So it kind of incorporates some of the AI technologies of Vidi into 3D bin picking, and that's from Covariant. On the right is an image from a product called Pickett. One of the nice things about the Pickett bin picking system is it's made for use with all brands of robots. So Pickett, for example, works equally with Fanuc and ABB and KUKA and UR. So if you have a diverse robot collection, maybe that's an approach you want to take. The cost of a bin picking system like this, of course, varies, but budgetarily $40,000 is what you're looking at. And if you kind of put that into perspective, often with this, you eliminate for perhaps a bowl feeder and other challenges. So $40,000 is a budgetary number for a system like that. Speaking of picking parts, we can lift up to about 175 pounds with a mobile order picker, as shown here from Tally. This allows for single person lifts. In the age of social distancing, anytime you can implement technologies to space out your employees, that's generally considered favorable. So the Tally mobile order picker is a great solution for that and warehouse optimizing. It's a battery operated device, typically lasts a single shift depending upon the number of picks and things of that nature, but typically it runs about 8 hours, and then batteries can be swapped out or you can recharge the device. A solution like this is about $50,000, and that does not include the pallet system. These can be moved with any number of pallet jacks. As seen in the bottom left, you have a motorized system, or it could be manual. Also of note, these mobile order pickers can be optimized so they could reach into shelving with very narrow openings. Many times you want to do picking to maybe grab some parts for your next run, or you're preparing a shipment. You can work within your existing racking systems in many cases to work with that narrow clearance between the top of the next shelf and the top, or the bottom of the next shelf and the top of the box. Much like the Tally mobile order picker, people often associate RFID with logistics. RFID is really exploding in the world of manufacturing and industrial automation. A common application that we all think of as RFID might be easy pass with your cars as you go on the turnpike. However, many applications ranging from change part management to work in process assembly tracking can be implemented with RFID. The tags come in many varieties, many packages, and some are just like ID. So they'll actually serve as kind of a barcode with more robustness. Oftentimes in a factory, a printed barcode could get removed or scratched or otherwise rendered unreadable, or RFID is a lot more of a robust way to do that. Other RFID tags serve as a small hard drive where you can read and write data. So for example, if you're using it for work in progress, you could log the operator who may have completed a certain operation, or if it's for tooling, as shown in the bottom left, you can manage the number of operations that occurred on the tooling, maybe between maintenance shifts, things of that nature. Entry price for an RFID system is about $1,000, and that'll buy you about a 2-inch working range. So price is generally a function of distance. Obviously, in the example of the Easy Pass system, that technology is a lot more powerful than the $1,000. But if you're reading from a few inches away, you can buy a system for about $1,000. As you get to distances used in manufacturing closer to 15 feet, you're probably looking at about $5,000 for a system. And then tags come in many formats. The tags can look like a bolt. So maybe you bolt it into your part that's moving down the line. They actually make paper. So if you have a traveler, the RFID tag's just embedded into the paper. Some systems, sort of as shown in the bottom right, allow you to read a bunch of tags at one time. So if you're trying to verify if all of the boxes are in the pallet that you expect or other kind of multi-read, there are some applications where you only want to read one thing in a certain area because it could be a problem if you're reading all the tools on the tool changer simultaneously. So those are things that the engineers help you select, but there are times when it is nice to stand at a distance and read 50 tags simultaneously. So that is some of the technologies available for RFID. That's often considered part of tracking and traceability. It's a term you often hear. In a similar way, edge devices, that's a term often associated with Industry 4.0. Edge devices create visibility, for operational efficiency. Really, if you look at what Industry 4.0 does, it tries to optimize robotics. Industry 1.0 was the assembly line, and 2.0 was the mechanization of those lines, and Industry 3.0 is robotics. 4.0 is making those assets work as effectively as you can. So if you've been confused by Industry 4.0, it's basically the next level of optimization after robotics is the best way to summarize that. So if you've not started your robotics journey, you might be better off focusing on Industry 3.0 with an idea of getting ready for Industry 4.0. However, if you have old machines as shown in the bottom right, edge devices allow you to get to Industry 4.0 quickly. They allow you to interface to existing machines and sensors, allowing you to kind of bridge that information from old machines to modern networks to create the dashboards and visibility to optimize the assets you already have. In many cases, plants can realize that they're underutilizing assets, allowing to address resources to improving utilization instead of maybe purchasing additional equipment. Edge devices can also be configured to be energy monitoring systems. At NEF, we often implement a system that goes into bag houses to monitor the efficiency of pulse valves in a bag house. You can do it for motor energy consumption. So there's many different ways you can implement an edge device. You can purchase the individual components to kind of get this dashboarding going for just about $500 to $600. More typically, you're going to buy a little system in a box and maybe you have someone create the dashboards for you. You're going to look at a budget there of maybe about $1,300. Of course, if you're going to do plant-wide integration or ERP system and really take this to the next level, you can easily spend 6 figures. But if you're just trying to get basic information from a machine, you're looking at an investment of about $1,000 to create the visibility, potentially more depending upon what additional capabilities and energy monitoring you want to add. Edge devices are a tool for older equipment. One of the concepts you hear that comes out of Industry 4.0 is digital twinning. It's really helps you understand what's going on with the robots in the field by having an exact model. In the image we kind of show here, you can see a robot picking up a part that might be part of a gear assembly, and then you can see the real robot doing the same thing. So digital twinning is really a way to simulate the robots down to the moves of an e-stop. Oftentimes, if you're sizing your guarding, you don't necessarily know where the robot will end if an e-stop is pressed anywhere along the path of motion. With digital twinning, you can simulate the e-stop, the robot will actually move virtually, and now you can figure out how to optimize perhaps your floor space so your guarding is as close as possible without the robot colliding into it. A high-end ABB Robot Studio program is one method that digital twinning exists. Robot Master or Octopus Visual Components are third-party packages that offer this kind of capability. In the case of an ABB robot, what's kind of nice is the digital twinning also generates your application code. So in many cases now your CAD designers, which may be limited in writing traditional software can actually write the moves to give you a head start. And if you're facing a shortage with software engineers, might allow you to bridge that gap a little bit. Companies like ABB will include this in their software, and they license their software typically for $1,500 a year. It is notable ABB has that software for free this year, so if you want to check that out, that is a possibility. Third-party components, such as the ones like Octopus and Robot Master, they can run around $15,000. However, they have the benefit of working with multiple brands of robots. We will provide more examples of the capabilities of this on the webinar on February 16th. Collaborative robots were designed to be very easy to use. So they will support digital twinning, but they don't often require those complex simulations and programming. In fact, many function packages are now available to address common applications. So, the Vectis solution, which is a welding solution, you can purchase for about $90,000, typically running in one day with no training, no on-site training. It shows up on a pallet within one day. You are welding parts. The expected life between any service on the robotic aspects of that system is about 30,000 hours. So if you divide the 30,000 into $90,000, it amounts to about $3 an hour for a welding solution. There is an NWRC webinar on that topic in detail on January 19th. Other solutions that are packaged that, again, skip the need for digital twinning because they just work out of the box include palletizing, screw driving, gauging. They can run around about $80,000 to $90,000 for a turnkey system. So for example, if you want to palletize boxes, you can buy that with a UR robot and usually you're able to service 2 pallets for about $87,000. Screw driving, gauging is a very interesting one down to the micron level. While you're picking up the part to move it maybe out of your machine tool into a tray, you could also be doing gauging and quality at the same time. Many people think of robots as really the main tool to aid in lifting. There's a range of tooling available, and TOWIE ergonomic lifters help safely move loads, rolls, barrels, cabinets, sacks, all the things that you can imagine needing to lift. Again, in this age of social distancing, this helps eliminate teamed lifts, which is a benefit perhaps. Systems like the PIAB PiLift, they have a computer on board. The image in the upper left kind of shows the output of that. It actually will tell you the load, which could be pretty handy. If you're picking up a box of something, it's a quick way for the operator to confirm that, is there 30 pounds of stuff in this product box? Because maybe something wasn't loaded properly. That allows also some energy consumption. The smart lift can reduce power consumption by about 76%. And something like that can pick up about 90 pounds. The system can be made to be mobile, as you see in the bottom left, where someone's moving a roll, perhaps for a printing operation, or attached to a bridge or a jib crane. Typically, an economy system starts at about $15,000. If you're going to start to add the Industry 4.0 features and load sensing, you're looking at about $25,000. There are systems available that support loads over 500 pounds. Those are engineered and tend to run a little bit higher than that. As shown with the TOWIE Smart Lifter, the industrial Internet of Things is really coming quickly. Another term you hear thrown around in maybe a non-concrete way is IoT, the industrial Internet of Things. The hub of many of those systems is IO-Link. IO-Link gives you the ability to download parameters to sensors. So, for example, if you've tuned up your analog distance measuring sensor, all those parameters can be stored on the PLC. So if later on you need to replace that, they're downloaded automatically through IO-Link. It allows the control of devices like Smart Lights, shown in the upper right, where you can use it for level control. So maybe it shows at one part of your process the level of a tank, the level of your roll. There are a lot of visual indicators. The studies that really come as part of Industry 4.0 indicate that visual data really helps you improve optimization, and that's kind of what the Smart Light does. That's part of the IO-Link tool set. For an example, another thing about IO-Link is the vacuum generator shown on the right. That's a PIAB product that has blow-off, vacuum sensing, many other controls. All of that is integrated over IO-Link with a standard non-shielded sensor cable. So typically you would need multiple valve controls for suction, for blow-off. You might need a sensor to measure pressure. All of that information is conveyed back over IO-Link in that complex device over a standard non-shielded cables. Analog signals become digital, and therefore there's a lot of noise immunity benefits as well. There's over 100 manufacturers that support the protocol of IO-Link: Rockwell, Festo, Siemens, SMC, Turk, Banner, Schmalz, Beckhoff, IFM, the list goes on and on. To give you an idea of the acceleration of IO-Link being accepted technology, in 2017, there were probably about 5 million nodes of IO-Link installed. In 2020, that number this year alone will be met. So another 5 million will be installed this year. IO-Link can really aid in machine startup. One of the nice things about IO-Link is they have web servers. So typically when you start up a machine, you kind of get the mechanics, you do the electrical, you get your software person on, and by then the machine's typically running behind schedule. With IO-Link, you could actually use the web server to start to configure the IO well ahead of the software team getting onto the machine, which can really speed up commissioning. Speaking of commissioning, another benefit of IO-Link is the decoupling of systems if you're shipping them. Now you can basically disconnect a cord set that connects to a network of hundreds of sensors as opposed to disconnecting hundreds of wires. IO-Link also shares parallel status. So one of the confusing parts of Industry 4.0 is whose data is it? If you want to have an ERP system that is monitoring a particular sensor or particular function on a machine, does that get routed through the PLC or does it come in parallel? Most IO-Link hubs, as offered by Balf, Phoenix Contact, etc., actually can allow parallel communication, so the machine controller, the PLC, is using the information for machine control, where enterprise level software is using the information for process efficiencies. A system like this can cost anywhere from a few $100 and up. Usually an IO-Link Master to get you the capabilities is about $300. Speaking of open interfaces, which IO-Link is, one of the things that's really underused that we see is, people like Yamaha, they make open AOIs. These allow for the control and integration of SCARA robots without ever having to touch Allen Bradley software. One of the most common reasons we see automation projects stall out, it's kind of fear of support. Most people have a staff of Allen Bradley comfortable PLC technicians. If you're able to incorporate robotics using proven capabilities where you do not need third-party software, you can leverage that existing skill set, hopefully moving forward automation. So people like Yamaha, when they release their AOIs, do so in an open manner. So if you want to modify the AOI underneath, it's not locked. If the AOI is not performing in a way that you expect, you can actually investigate what's going down underneath it, which a lot of controls engineers appreciate. One of the things about robots that I think is often misunderstood is that, when you build your own, you can certainly piece together a servo motor and an actuator and a gearbox and the cables. Cable management is often an afterthought in those roll your own automation systems. In the case of Yamaha and SCARA robots of the like, the cable management is engineered. 70% of the reason there's downtime in automation solutions is cable management. I would submit to you it's probably because most people don't think about it as they're building roll your own systems. With package technologies and robotics, cable management is engineered and integral to that, reducing that downtime risk. Many of these SCARAs are available. SCARA, by the way, is generally a 4-axis robot, X, Y, and Z. In the case of Yamaha, you can also control Cartesian robots that come with the cable management pre-installed. SCARA robot with an Ethernet IP interface would be about $14,000. The definition of what a robot in manufacturing is can be unclear in my experience, but it's mostly often thought of as a multi-axis system. However, Yamaha offers single-axis robots. In many cases, people use pneumatic systems in these because of the initial purchase price and the ease of installation. Yamaha has a line of trans-servo products that support up to 90 pounds of load. You can have strokes over 6 feet, speeds over 1 meter a second. Your average price for the actuator, the motor, the drive, the cables, a turnkey system is about $2,300. One of the things people don't often consider is the energy savings of moving away from pneumatics. So many times that $2,400, which is a very attractive price, of course, pneumatic system like that might be $1,000. That bridge is gapped very quickly if you look at the operational costs. Of course, also you're getting the benefits of positional control, multi-position accuracy, jerk control. long life. So there are many reasons that these single axis robots have a place in the market. Speaking of energy savings, a key new technology in energy savings is the patented MAC pulse valve. This is used on pulse jet dust collection systems. Essentially, all the pulse jet systems have different brands of the same diaphragm valve technology. In the graph in the upper left, you can see the blue trace is the output of a pressure transducer at the blowpipe of such a system using a diaphragm valve. The yellow trace is the MAC valve. What you're going to notice is using the same header pressure, the MAC valve yields a much higher peak and a much higher acceleration, which yields a much better cleaning capacity. So that's kind of a big benefit there. What you can see is the outcome of that in the application in the upper left. This is the image inside of a bag house that where the fan was turned off, so no additional debris was being added. 3 cycles were made into one of the stations. You can see the amount of the additional material knocked off the bag simply by the MAC pulse valve. The image in the bottom right on the left side of that image shows the filter is blinded because the diaphragm valve had failed. A MAC valve was installed, and several cycles later, again without running the fan, you can see the cleaning power available. A lot of people will use that technology to either reduce the headache pressure, perhaps also take advantage of benefits like extended bag life, reduced labor. The typical diaphragm valve life is 1 million cycles. The typical spool life is used in a MAC valve is 10 million. So you're getting an operational benefit in the amount of time you're going to have to spend maintaining that. You are looking at the average price of about $400 each, which if you're comparing it simply to only the purchase price of a diaphragm valve is about 10 times more. However, when we couple this with data collectors and some of the edge devices we use to study these installations, we find that the ROIs typically are 8 months, even though the initial purchase price is 10 times more. So that's definitely a new technology. Speaking of affecting the bottom line with technology, this is, I thought was pretty interesting. Victor Grizzle is the CEO of Armstrong World Industries. Armstrong World Industries does about 1.2 billion with a B in revenue. And here you can see a snippet of his call from February, where he is citing the installation of sensors to the shareholders. You know, often we may wonder, you know, how things like sensors or IO-Link and some of these other technologies we're talking about affect the bottom line. Here you can see the CEO telling shareholders how it made them more money. So I thought that was a really concrete way to express the real benefits you can realize from these technologies. One tool in that area that can be used is a conditioning monitoring sensor. This from Balf is a sensor that's about 1 inch by 1 inch by 1/2 inch. It measures various parameters such as 3 axis of vibration, surface temperatures, humidity, ambient pressure, and it really then allows you to capture information about start cycles, operating information, and can be an important tool for either edge devices or existing installations. A sensor like this costs about $250, and they're packaged in stainless steel in both IP67 and IP69K options. Of course, when it comes to impacting manufacturing, most people think of robotics. Most people are not really aware of the concept of cooperative robots. This is made possible with technologies like ABB Safe Move 2. So what this will allow for operations like painting, welding, machine tending, assembly to be completed with traditional industrial robots without hard guarding. Just like with new collaborative robots, when using ABB Industrial, you still need to do a risk assessment. That's always required really for any application that has motion. But when you're able to deploy this technology, it really opens up new worlds of robots and reducing floor space with traditional industrial robots. As the #1 distributor for universal robots at NEF, we often run into a lot of great applications for collaborative robots, but the weight limit on them tends to be about 16 kilograms or 30-some pounds. This allows you to extend into the whole new world. The average price for industrial robots can vary greatly due to the reach and the payload, but I would say it's about $60,000 when you're including technologies like Safe Mode 2. But, you know, they can support payloads perhaps over 1,500 pounds with reaches over 1,400 feet. So that's kind of a very, in my opinion, misunderstood application of industrial robots. Again, Safe Move 2 allowing you to run them without guarding. I don't know how many people ever wonder what makes industrial robots possible, but the answer to that is really Nabtesco. I won't cite specific brand names, but many times if you're calling your robot supplier for grease, they will actually be giving you a Nabtesco part number. That's because Nabtesco is one of the most common joints used by all the major robotic manufacturers. And the reason is it's very high rigidity. You know, the definition of automation is, of course, doing the same thing repeatably over and over. A robot that wouldn't be able to position in a repeatable way would not be very useful. What makes that possible is the technology employed by the Nabtesco cycloidal gearbox. These are used in many applications outside of robots, rotary index tables, fifth axis positioners, all kinds of things. A rotary index table that could kind of accept any brand of servo motor that would support, you know, maybe we'll call it a 36 rotary index table. That index table with the Nabtesco, you could put 450 pounds on the edge of that 36-inch table, index 45 degrees in about a fifth of a second. It has about 1 arc minute of backlash, and that's about $2,000. So very, very effective package solution that allows you to leverage what's been proven in robotics in your application. If you want to use this as that's if you use it with your brand of servo motor. If you want to buy one of these systems standalone with an HMI, you're looking at about $5,000, and that gives you all the acceleration control, multi-positions. There's no hard programmed cam positioning involved. Of course, while Nabtesco makes robots possible, one of the cool technologies, wireless inductive couplers make robot applications better. You know, you can support, believe it or not, up to 5 amps of power transfer through free space. Think of your toothbrush charger like you might have at home. Balf inductive couplers are really an outstanding option for change parts, end of arm tooling, rotary index tables, or other places you have cable management's a challenge. Some of the options, in addition to power transmission, allow you to transmit discrete signals through the air. These can be really helpful when you're coupling up, for example, to an end of arm tool and not have to worry about the wire management. Some of the systems also support bidirectional communications through free space that allow you to have I/O link. So all the great technologies of I/O link can actually be bridged over this wireless inductive coupler as well. You're looking at about $1,000 for the average cost of an inductive coupler. So, you know, this was meant to be a very high level summary of 16 automation technologies that are really kind of, in our experience, underused. We didn't try to dive, obviously, too deeply into anything out of respect for your time. It looks like we ran closer to 35 minutes there. But hopefully with the pricing and some of the application examples, you can picture where you want to apply this in your processes. And with that, we'll open the floor up for questions.
Thank you, John. We currently do not have any questions in, oops, one just popped in. So someone just read my mind. I was going to say, if you have a question, now is the opportune time to go ahead and put that in the Q&A box. And the question is this recorded? Yes, it will. It is recorded, and you will get the link in a day or two from me. So if you don't see that, feel free to reach out to me. So if anyone else has any other questions that they'd like to pop in, please go ahead and do that now. We'll go ahead and give that a minute. While we're waiting, John, do you have any final thoughts or comments or anything additional that you would like to say while we just give people a chance to put a question in?
No, I mean, I think that we at NEF and other people who do like we do, we see ourselves as a tool to help supplement your short resources. It's very common. We see a lot of manufacturers and those wanting to implement technology a bit stifled by the ability to implement them. The idea of companies like NEF is we hopefully provide you with an honest assessment of the risks and allow you to implement and decide to go forward with ones that affect your bottom line and not lead into science fair projects. So, you know, we have a passion for this, and we see ourselves as an extension of your company. Ben mentioned family. I've owned other companies in the past. I've done different things, but the reason I continue to do this job is every time I drive by buildings like people on this call, I feel like I made a difference there. And so hopefully we get a chance to perhaps do that for you, because certainly the future of the state's economy is very dependent upon the strength of manufacturing. So we do believe in supporting that.
We did just have another question come in. And it is, are you able to take an existing UR robot and add a welding solution to the system?
Absolutely. Yeah, so you're in that case, I mean, I guess well, let me qualify that. The UR10, which is the longest reach UR, is the typically used UR in a system like Vectus. We in Pennsylvania have several Vectus installations with references we can provide. They're a company based out of Colorado. If you get in touch with me, I'll be happy to get you in touch with them and you can buy directly from them. But if you have a UR3, that's probably not going to be very, very useful. So it's really going to depend on the reach. But if you have a UR10, absolutely. If you have a UR5 or UR3, possibly not. But get in touch with me and I can get you in touch with the one of the founders of Vectus who can answer that. But you're probably looking at about a $40,000 package to convert that. And again, that solution is very turnkey, which has been pretty powerful to those who've taken advantage of it.
Great, thank you. We have another question. Do you manufacture the robots or are you a broker for other companies? And who is your referred source of palletizers?
Sure. So NEF is, a distributor for automation technologies. So we package at NEF what we believe are the best of breed manufacturers to bring solutions to the market, and there are other brands. So NEF does not make robots, but what NEF can do, and we often do, especially for manufacturers who have limited resources, if we offer QC conveyors and Cognex vision and MAC valves and robots, all of which are needed on a project, we can package them together for you with the idea that you do your own programming installation. So if you kind of want that as a system, we're the #1 AD distributor in the country, we can make that starter system. We're not an integrator. We have a broad partnership with about 35 integrators. So if we begin a project with you and we determine that you would be best served by a turnkey solution, we can transition that seamlessly to integration. So we try to work with you at the component level, the subsystem level, and the system level. The second question is, as far as preferred for palletizing, there are several solutions out there. We try to be somewhat agnostic in the sense that there are many of them. We've had very good luck with the Wynexia system, and part of that preference simply because it's made in Pennsylvania. We know the owners very well. There are other systems out of Chicago. If you want to reach out to me, I'll happy to email you links to many of them. But Wynexia, from a UR standpoint, has one we've been successful with I think about 6 installations, and that solution runs about $87,000 with the robot. So that's you buy it from Wynexia, it shows up for about $87,000.
Okay, thank you, John.